Okay, let us continue the third part of today's class. Okay, for the matched filter detector, it is easy to show that Okay, it is easy to show that x0 squared over 2 sigma squared is just the symbol energy Es divided by the noise density N null. Which will be called gamma S. Okay, let phi is be equal to pi minus theta plus psi. Then okay, d phi is equal to minus d theta. Okay, theta is equal to 0 implies that phi is equal to pi minus psi. Okay, because phi is equal to pi minus theta plus psi, when theta is equal to 0, okay, so this term becomes 0, and phi is equal to pi minus psi. Okay, and okay, theta is equal to pi minus psi implies that phi is equal to 0. Okay, because when theta is equal to pi minus psi, okay, this equal to pi, and then pi minus pi is equal to 0. And minus psi, So this equal to minus psi is equal to 0. Okay, finally, the final form of PM is obtained. Okay, PM is equal to 1 over pi, and 0 must be changed to, okay, when theta is equal to 0, phi is equal to pi minus psi. And when theta is equal to pi minus psi, phi is equal to 0. So the upper limit should be changed to 0. And x0 square over 2 sigma square can be changed to gamma s. Okay, like this. And theta plus psi, okay, theta plus psi is equal to pi minus phi. And d theta is equal to minus d phi. Okay, this should be pi here. And this is minus, and this is phi, and this is the minus. Okay. And this is equal to, okay, you can exchange the upper limit and the lower limit of the integration. Okay, so you can change the lower limit to 0 and the upper limit to pi minus psi. Okay, like this. Okay, so and sine of pi minus phi is equal to sine of phi, like this. And because we have changed the upper limit and the lower limit of the integration, so this minus can be removed. Okay, so this is equal to d phi. Okay. Okay, the bit error rate BER for BPSK is, okay, I think you should have learned it when you take the course Digital Communications. So it is equal to this. Okay, so P2 is equal to 1 over 2 times ERFC of the square root of gamma B. Okay, where gamma B is equal to EB over N null, and EB is the bit energy. For BPSK, gamma B is equal to gamma S. Okay, because for BPSK, each symbol only conveys one bit. Okay, by equating equation 18, okay, this equation to equation 17, okay, this equation for m is equal to 2, okay, because we know that the BPSK only has two different signal, okay, so m is equal to 2. That is psi is equal to pi over 2. Okay, do you remember what is psi? Okay, let me show you the definition. Okay, psi is equal to the pi over m, okay, in figure 1. Okay, we obtain okay, 1 over 2 ER of C of the square root of gamma B is equal to 1 over pi and pi minus psi. Okay, now psi is equal to pi over 2. Okay, and exponential minus gamma S. Okay, for BPSK, gamma B is equal to gamma S. So we can replace gamma S by gamma B. And sine square psi, okay, psi is equal to pi over 2. Okay, here. And over sine square phi, okay, d phi. Okay, so we get this equation. Okay, now let x be equal to the square root of gamma b. Then first we can move this 1/2 to the right hand side of the equality. So this becomes 2, and this can be deleted. And gamma b is equal to x. Okay, like this. So here gamma b is also equal to x. And the pi minus pi over 2 is equal to pi over 2. And the exponential minus x times sine square of pi over 2. Okay, because sine of pi over 2 is equal to 1, so this term can be cancelled like this. And the sine square of psi, okay, we can replace this by phi, okay, and replace it by a parenthesis like this. Okay. Okay, so finally, ERFC of x is equal to 2/pi times integration from 0 to pi over 2 and exponential minus x squared. Okay, sorry, x over sine square phi d phi. We call this equation 20. So this concludes our solution. Okay, we place a black square here. Okay, do you have any questions? Okay, sorry, this should be x squared. Okay, I forget it. Okay. Okay, so let's go back to the slides. So we have proved the equation 1.7. Okay, it follows that we multiply equation 1.7 by alpha on the both sides. Then here is alpha, and here is an alpha. And we replace x by the square root of beta times rho, and the x squared becomes beta times rho. Okay, then we get this equation called equation 1.8. Okay, next, since rho is equal to summation I is equal to 1 to nd rho I, okay, where nd is the diversity order with MRC, that is the maximum ratio combining. It follows that the average BEP, okay, that is the bit error probability, is given by P bar B is equal to the expectation of PB of rho with respect to rho. Okay, so we can take the PB. Okay, PB is equal to alpha times ERFC of the square root of beta rho. And we use this equation, okay, equation 1.8. So, and we move the expectation inside of the integration. Okay, so we have 2 alpha over pi. Okay, 2 alpha over pi is come from this term, and the integration from 0 to pi over 2. Okay, this is come from this. And the expectation of this term. Okay, originally it's exponential minus beta rho. Okay, so this is exponential minus beta rho, and we change rho to this term. Okay, so this is equal to the summation I is equal to 1 to nd rho I, and over sine squared theta. Okay, over sine squared theta, and with respect to rho and d theta. Okay, next, because the expectation of the sum of many numbers, okay, is the because the exponential of the sum of some numbers is the product of exponential of each number. Okay, so this equation can be rewritten as 2 alpha over pi. Okay, here 2 alpha over pi, and the integration from 0 to pi over 2. Okay, here integration from 0 to pi over 2, and the expectation with respect to rho. Okay, here expectation with respect to rho, and we move the summation out of the exponential. We will get the product from I be equal to 1 to nd, and exponential minus beta rho I. Okay, exponential minus beta rho I over sine squared theta. Okay, here over sine squared of theta, and d theta here. Okay, assuming Rayleigh fading, it can be shown that the SNR on each diversity channel is exponentially distributed. Okay, why? Do you know why? Okay, let us see the blackboard. Because I do not have blackboard, I use the Word. Okay, instead. Microsoft Word. Okay, this is chapter 1 and page 132, and problem 1. Okay, assuming Rayleigh fading, show that the SNR on each diversity channel is exponentially distributed. Okay, here is the solution. Okay, on the ith diversity channel, the received signal can be modeled as it is 25 minutes. So we have complete today's class. See you next time. Goodbye.